Example 3, solve equations with repeated factors. So with this problem here, I'm going to, first thing I got to do if I'm going to try to solve it, I got to add 64 to both sides because I want my quadratic equal to 0. Otherwise, I can't use the zero product property. Well, now I've got a problem where I want to factor stuff out. 9 is divisible by 3. Is 48 divisible by 3? No. Oh, it is. What about 64? Ah, dang. Almost. Almost divisible by 3, but not. Okay. So that means I just have a general trinomial. Because, well, it might be a perfect square. Let's check. Because 9x squared, you take the square root of that, you get 3x. And the square root of 64 is 8. Well, what is negative 2 times 3x times 8? So that's negative 6 times 8x. Ooh, that's negative 48x. Good. I didn't really want to try to find the factors of all the factors of 9 times 64 and try to add them up. I found it's a perfect square. So this factors into, excuse me, 3x minus 8 squared equals 0. Well, if it's squared, that means 3x minus 8 times 3x minus 8 equals 0. Well, you notice how it's the same root? That's where it comes in when they're saying repeated root. It's the same thing repeated twice. So I only actually need to find one of them. 3x minus 8 equals 0. Add 8 to both sides. I have 3x equals 8. Divide both sides by 3. And we have x equals 8 thirds. And one thing you can do when you write down your solution of x equals 8 thirds, you could just say repeated. Or you can say x equals 8 thirds and 8 thirds. Either one of those work. The repeated one works better. That way you don't accidentally put a negative sign on one of them and mess up your answers.